Good afternoon, guys. Welcome to domain analytics session. So, as we know, in yesterday's session, we are talking about decision trees, guys. So, what is decision tree and what is the purpose of it? So, we have seen it, right? So, the agenda, what we have seen was the introduction, decision tree in algorithm, how this decision tree will be used in algorithms, okay, like machine learning algorithms, okay, and what is the importance in automative analytics using this decision tree, and we'll be seeing the conclusion. So guys, in yesterday's session, as I said, we have seen introduction. So decision tree is nothing but it is a supervised learning technique, okay, that can be used for both classification and regression guys. But most probably and most preferably, it is used for classification problems. Okay. And why it is called decision tree? Because it is a small tree. Okay. It starts with a root, which expands to further branches on constructs a tree-like structure. A decision tree simply asks a question based on what? Based on yes or no. Okay. So this decision tree, guys, basically, I can say it is a very simple tree which starts with the root and node, and it can ask us a question like based on the answer yes or no. Okay. So we have seen what is decision tree. And the next thing we are going to see is decision tree in machine learning algorithm. So how this decision tree will be used in this machine learning algorithm? Okay. So guys, decision tree for predicting, okay, this machine learning, how it is useful means in a decision tree for predicting the class of given data set, the algorithm starts from the root node of the tree. Okay. The algorithm compares the values of root attribute with the record and the attribute based on the comparison. Okay. It always follows the branch and the jumps to the next node. So basically, how this decision tree used in machine learning algorithm? So decision tree in machine learning algorithm, as I said, decision tree is nothing but a supervised machine learning. It is used to categorize or make predictions based on how a previous set of questions were answered. Okay, so the model is from supervised learning, meaning the model is trained and tested on a set of data that contains the desired categorization. Okay, guys. So how this machine learning, the decision tree is used? A decision tree is a type of supervised machine learning used to categorize or make prediction based on how previous set of questions were answered. Okay, the model is form of supervised learning. So what I'm saying in the sense is the meaning of that model is train and test data. The set of data contains the desired categorization. Okay, so how decision tree are used in learning? So guys, how this decision tree is used in learning? Decision tree learning employs a divide and conquer strategy, okay, by conducting a greedy search to identify the optimal split points within a tree. So this decision tree always follows the rule divide and conquer by using the strategy of conducting a greedy search. Okay, we're going to identify the optimal split points within a tree. This process of splitting is then repeated in a top-down recursive manner until all or the majority of records have been classified under specific class labels. Okay. The process of splitting, okay, it is repeated by top-down, the recursive manner, until we get the majority of records which have been classified under specific class labels. Okay, guys. So, what is this decision tree and example? Okay. So, if you ask me any example of decision tree and example, I said it is one of the supervised learning. Okay. So, it is nothing but one of the supervised learning. It is one of the supervised learning. Okay. So the algorithm can be used for, I know, we know that it's used for both classification and regression, right? It is for both classification and regression. And yet I can say as it is used for both classification and regression, but most probably and most frequently, it is used for classification. Okay. And this decision tree follows a set of if-else conditions. If-else conditions to visualize the data. Okay, and classify it according to the condition and classify according to the conditions. Okay, guys. So if you ask me, what are the main advantages of decision tree? So the main advantages of decision trees, it can handle both continuous and categorical variables. So the main advantage is it can handle both continuous and categorical variables. Okay. So the execution of this decision tree algorithm must be possible without having to scale the data as well. So while utilizing this decision tree algorithm, guys, it is not necessary to create the missing values. Okay, while utilizing this decision tree, it is not that much important, like not necessary to credit the missing values. Okay. So if you ask me any good example of decision tree, a decision tree is a very specific type of probability tree, okay, that enables you to make decision about some kind of process. For example, you might want to choose between manufacturing item A or item B. So investing in one choice, investing is first choice, okay, choice or choice three. So which choice you are gonna invest? Like let me say in the stock market, there are a bunch of things. So in which thing you are gonna apply your money? So spend your money, invest your money. So using this decision tree, we can use it, okay. So it enables to make us decision on which thing we have to invest our money, okay. It either gives yes or no, as we know, and when it gives yes or no, it is going to give us the components of trees, guys. Okay. If it is giving yes, it will be having some components like this. Okay. The tree, right? The tree. And if we give no, it will be having some of the components like tree structures. Okay. The no. So these things will be done by this decision tree, guys. And this decision tree always work with this principle of graphical representation, okay, of all possible solution in a decision based on certain condition. Okay, a decision tree is a graphical representation of all possible solutions to decision based on certain conditions. On each step or node of decision tree, we are used for classification. We try to form condition on the features, separate all the labels, classes contained in the data set. Okay. So the types of decision tree we have seen. Okay. So the advantages I have said. So let me say you the disadvantages. So guys, the advantages we have seen is it's less data preparation, one thing, non-parametric, like, okay. So basically it's going to take the data and give us a solution. It may give us 100% of the data, okay, without training. But here the disadvantages you're going to ask is overfitting will be more, guys. Okay. The disadvantages of decision tree. Disadvantages of decision tree is overfitting. Okay. Feature reduction and data resampling, optimization. Okay, these things we can see. The disadvantages of decision triggers. Okay, so first thing is overfitting, feature reduction, and data resampling, the optimization thing. So these things probably we can see the disadvantages of decision. Okay. So to solve this overfitting, we'll be using something called as a random forest, guys. Decision tree means a single tree. Random forest, the name itself, the terminology says random forest means a lot of trees you can. Okay. You can ask me a question, is decision tree a model? So in computational complexity, the decision tree model is the model of computation in which an algorithm is considered to be basically a decision tree. In the sense, a sequence of queries or tests that are done adaptively, the outcome, the previous test can influence the test that is performed the next. Okay, so this is all about the decision tree, guys. And if you ask me, okay, what problems can decision tree solve, right? A simple question, what problems the decision tree can solve? So guys, they can be used to solve both regression and classification problems. We know that, and most probably used for classification. So decision tree uses the tree representation, okay, to solve the problem in which each leaf node corresponds to a class label and attributes are represented on the internal node of the tree. So guys, it can be used for both regression and classification. Decision tree uses the tree representation to solve the problem in which each leaf node corresponds to a class label and attributes are represented on the internal node of it. Okay, guys. And moving on, we'll be seeing is decision tree clustering used for clustering? Okay. So decision trees can also be used to perform clustering with few adjustments. Okay. So that was a good question. So decision tree can also be used to perform clustering with few adjustments. On one hand, like I can say new split criteria must be discovered to construct the tree. Okay, without any knowledge of the samples, the labels. On the other hand, the new algorithm must be applied to merge subclusters into leaf action. Okay, so these things they can be used. Okay, so these are the decision tree in machine learning. And next thing, if we go, is decision tree. How we are going to use to solve this? Okay, is decision tree machine learning or data mining? Okay, so guys, decision tree learning is a method commonly used in data mining. Okay, the goal is to create a model that predicts the value of target variable based on several input variables. Okay, a decision tree is a simple representation for classifying examples. Okay, so decision trees for classification. So why we use most probably decision tree in classification itself? So guys, basically classification trees, the decision tree is used for yes or no. And in classification, same things we are going to do. Okay, the classification, the example. Okay, like let me say there is a person going. Will he reach the destination or not? Yes or no? Depends on that. That much. Okay. If he reach, it says. If it is no, no. But in regression, continuous data types. Okay, the outcome, the variable will be continuous. Like example, like number like 1, 2, 3. Okay, working now. Okay, these things will be coming under regression trees. Okay, so let me say the introduction of starting with decision tree. So decision tree is a type of supervised machine learning. Okay, in the sense we explain that input is the corresponding output is the training data, where data is continuously split according to certain parameters. The tree can be explained by two entities. Okay, named by decision nodes and leaves. These leaves are the decisions are the final outcomes, and the decision nodes where the data is. So let me give an example. Is a person's fit? Is a person fit? So let me take age greater than 30. Okay. Yes, no. Is a person fit? How to check it? Let me write it in some. So let me add a slide here, guys. So you'll get some idea when I'm going to explain. So new slide. Okay. So here, let me explain you about is a person fit. The question in the decision tree is a person fit? Okay. So now we are going to do decision tree. So I'm going to take his age. So age is less than 30. Okay. And I'm going to say is a person fit. How we are going to check? Yes or no? So guys, to be fit, what we have to do? He should exercise. He should maintain his diet, something like that. So let me say in S, eats lot of pizza. Okay. And no, exercises in the morning. Okay. So if he eats lot of pizza, of course, what is coming in your mind? Okay, he's not exercising, he's eating pizza and many more foods. Okay, which is contains a lot of calories and something. Okay, so yes, easy fit, easy it is unfit, right? Is it fit or no, guys? You can only calculate here. Again, exercises in the morning. Yes, if he exercises in the morning, so let me change the color here so you understand it easily. So if he eats lot of pizza, So what happens, guys? Gradually, he is unfit. Yes, he is unfit. No, he is not fit. Right? If he exercises in the morning, yes, he is fit. He is not unfit. Okay, no. So let me write it as. So here, guys, this is how decision tree. Okay, a decision. This is an example of decision tree, which can be explained using this binary tree. Okay, so let me say you want to predict whether the person is fit in given their information like age, eating habit, and physical activity. So the decision nodes are here questions like what's the age? What is the age? Okay, does he exercise? Does he eat lot of pizza? So here it is we are asking if he eats lot of pizza, does he exercise in the morning? Okay, and the leaves it's gonna give SR. So which are outcomes like either unfit or fit or fit or unfit. In this case, the binary classification problems, guys. Okay, this is the binary classification problem. Binary classification problem. Okay, so classification trees like yes or no. Okay, so these things it's like a classification. Regression tree means it's going to go for continuous data like 1, 2, 3, 4, 6. Okay, he is working now. That is called as regression. So in this case, decision trees, we are not going to use decision tree most probably. If you're having continuous data, we are going to avoid decision tree. But when we have binary classification problems, we are going to use decision tree. Okay, decision tree like we are going to use what are the types which is useful for us. Okay, here you can see is a person fit? That is a question for us, and we can see what are the things will be given age 30. So I'm going to consider yes or no, the leaf node, and I'm going to say if he eats lot of pizza, of course, if he eats lot of pizza, junk foods, if he is taking more calories than the usual intake, of course he's going to increase his fat and he's going to become fat, right? So being fat, that is not a bad thing. But here, what question we have is if he eats lot of pizza, is he unfit or fit? Okay, that is the thing we are going to calculate here. And he is unfit, of course. And if he exercises in the morning and he's doing a lot of work and he's maintaining his diet, of course he is fit, guys. So I can run. Okay, so everything is done. So being fat has his own advantages. Being thin also having own advantages. Okay, being fit we have advantages. Okay, being unfit I don't have. I don't think we have any advantages. Okay, so this was a simple example of this decision tree. Okay. So next thing, next thing we'll be saying is entropy, guys. Entropy. So entropy is called as Shannon entropy. Okay, it is denoted by H of S. Okay, means I can say for an infinite set, and the measure of the amount uncertainty or randomness in the data. So if you ask me the formula for entropy, I can say H of S is equal to summation of x p of x log square 1 of p of x. So initiatively, I can say it tells us about the predictability of the certain event. Okay, so sorry for this. Let me write it again. Okay, so this is nothing but p of x. Okay. So basically, it tells us about the predictability of a certain event. Example, I can say consider a coin whose probability of head is 0.5 and probability tail is 0.5. Here, the entropy is the highest possible since there is no way of determining. I'm saying my head is 0.5 and my tail is also 0.5. So here the entropy is the highest possible since there is no way of determining what the outcome might be. Alternatively, consider a coin which heads on the both sides. Okay. The entropy of such event can be predicted perfectly. So this type of alternative consider, like I'm going to consider a coin, heads on both sides. So what will be the entropy? If the coin has both head and head, of course it's one, right? 0.5 and 0.5. So I'm saying it's one. If we have head and tail, it is little difficult to guess the probability. So since we know beforehand that it will always be head, so I'm saying in a coin, both are head. So beforehand, we will be knowing it is always heads. In other words, this event has no randomness. the coin has both head only, there is no randomness, right? There should be a randomness. What I'm talking about entropy. Randomness means head and tail should be there. Of course, we know the coin is printed with head only. There is no randomness. Hence the entropy at that time will be 0. If there is no randomness at that time, the entropy will be 0. In particular, lower values, it's going to imply less uncertainty, while higher values imply high uncertainty. Okay, so this was about simple explanation about entropy, guys. Okay, I hope it is clear. And next thing we'll be seeing is information gain. Okay, information gain. So information is gain is also called as Kullback Leber. Okay, divergence is called as Kullback Leber. Divergence. So it is denoted by IG of S. Okay, S comma A, guys, is different. For a set S in the effective change in entropy after defining for particular attribute. Okay, so it measures the relativity change in entropy with respect to the independent variable. So if you ask me the formula, so alternatively, it is nothing but formula will be this will be the formula, guys. Okay, so I remember this formulas. This is not is equal to. Okay, so this is the formula we have information gain. Okay, where IGSA is the okay. It is I can call IGS as the information gain. Okay, and HFS is the entropy of the entire set, where P of X is the probability. P of X is the probability. So this was all about the information gain, guys. Okay, so we'll be seeing what type of the next things we can see. So guys, this was about decision tree. So I have given a lot of introduction. So moving on, we are seeing decision tree classification algorithm. Okay, next thing we'll be seeing is decision tree classification algorithm. Okay, so it is a tree structured classifier where internal node represents the future of the data set. So it represents the decision rules, and each leaf node represents the outcome. Okay. Decision node has both leaf nodes. It's a subtree. Okay. Leaf node, decision node, and we have different kinds. Okay. So this was about decision tree algorithm. So why do we need a decision tree? Okay, so why do we need decision tree? Let's see. Okay. So why do we need decision tree? The first question is. So suppose there is a person who wants to buy a new gas type of automatic car. Okay. To solve this problem, we'll be using decision tree of root. Okay. Car. So we'll be seeing manual or auto. So gas. So is he gonna buy like petrol car? So Okay. And if it is diesel, we are not gonna buy. So how decision tree in automotive analytics? So decision decision tree. So decision tree in automotive analytics. So generally to make decisions manually, it's time consuming of labor intensive process. Okay. So we are going to evaluate the condition of car before purchasing the place, and we're going to play a crucial role in decision making. Okay. So while we are evaluating the condition of a car before purchasing anything, we're going to make a crucial role in decision of making. So for one vehicle, there is 1,000 of parts. For assembling of these parts, good decision accuracy should be taken. Nowadays, we can see Toyota Innova takes 1.6 minutes by using machine learning. Okay, so we can leverage machine learning techniques to develop automatic system for automobile evolution. Okay, showing promising results, the classification short business problems. Okay, so that means that was our decision tree, how we are going to use in automotive analytics. Next thing, conclusion. Okay, decision tree has been so decision tree has been found useful in classification and prediction modeling due to the fact where it can be capable to accurate discover hidden relationships between variables. Okay, it is capable of removing insignificant attributes of the data set. So basically, decision tree can handle both continuous and categorical variables, guys. The execution of the decision tree algorithm must be possible without having to scale the data as well. Okay, while utilizing the decision tree algorithm, it is not necessary to create the missing. So this was all about the decision tree theatrical things, guys. Now we'll be seeing how we are gonna implement this decision tree. Okay, so how we are gonna implement. So going to the code part, guys. You can see I have imported. So this is a Google Colab. So in this, I have got a data, guys. Okay, so we'll be checking what is the use of decision tree. Okay, so what type of car will be good. Okay, so as we know, it is like we are used for classification problems most probably than continuous data. So decision tree. So I have imported the libraries, guys. Okay, NumPy as linear algebra, pandas as data processing, data manipulation, you can say, matplotlib for. So let me write it down for you. So NumPy we have done it for linear algebra, and panda for data processing. Okay, like I can say, or data manipulation. And we'll be seeing matplotlib for graphical representation. Okay, for graphical representation, I will be using this. And for Seaborn, okay, I have imported Seaborn too. For scientific calculator, you can call it as advanced data visualization. Okay, so I have imported the libraries. These are called as libraries. Okay, so these are called as libraries which are imported. So after importing the libraries which are necessary for us, I'm gonna take the data set, car evaluation data set. Okay. So this is my database. Okay. I have given a variable name as data and I have given car the data set path. Car evaluation data. Okay. So after that, I'm gonna read my file. Okay. So after reading the file, I'm gonna see what all things I have. So I have 170, 1728 rows and some columns. So what is this V high? Small, low, unaccurate. So guys, you don't have to get confused. Okay. So when I have done exploratory data analysis, so df.head, okay, df.head, it's gonna give us a first five. Okay. So the shape, car X. So guys, here you can see the column names. Okay, you can see the column names. Here we have 0, 1, 2, 3, 4, 5, 6. So it is not that much giving us the full clarity. So buying, meant, doors, persons, both safety and class. So these are our columns. So car accessibility. So price, overall price. Okay, the buying price, the maintenance price, the comfort, the code, the number of doors, and person capacity. Okay, how much person can carry, or the size of the luggage boot. So it is a small one. Or so guys, whenever I say a car, so as we know, we are doing a car evaluation. So when I say car, basically you can think about, so how many space it has, what is the horsepower, so what type of the minimum weight it can carry, what is my luggage boot, how much it can store. So basically when I say car, you'll remember like that, right? So when we say I-20 or something, you can take, okay, 5 space, person is 5 space, and overall price is okay, that is good. And how many number of doors we have. Okay, so we will be having doors like 4 and back 7, right? Okay, then how many types of capacity, person capacity, of course it's 5. Then the luggage says how much type of luggage it can carry, and what is the safety estimate, how many, I can say, like how many airbags it has. Okay, so these things you can see. Okay, so the column names are by, meant, doors, persons, and luggage. So guys, after that, I have renamed my column. Okay. Here you can see I had 0, okay, 0, 1, 2, 3, 4, 6, and so. Okay, so I want my data to be more clear, as it doesn't make any sense. I have given this. So after that, I have renamed my columns. Okay, so here I have renamed my columns to these things: by, mentors, persons, board, safety, and plus. Okay, so here guys, what is the why I'm applying this? So when I say 0, 1, 2, 3, 4, 5, 6, it doesn't make any sense, right? So what I have done, I have renamed my column. Okay, I have renamed my columns to these things. So after renaming these things to columns, and I'm gonna apply it. So I'm gonna check it. Is it got applied or not? Okay. So after applying all the columns what we have, okay. So after applying, we'll get the idea. Okay. So these things has to be done. Okay. So after renaming the columns, we'll be getting some idea. So what type of data is useful for us? Okay. So after applying what is useful for us after getting the column. Okay. So after renaming the columns, we'll be seeing the info what we have in the thing. Okay. So what info we have? So when I write data frame.info, okay, df.info, it is so it is gonna give me the information. Okay, so buying, so there is no null objects. Okay, in buying I don't have, in mean also I don't have, and those I don't have any, luggage boot, safety classes, I don't have any non-null object, guys. Okay, and the memory usage is nothing but 94.6 plus gigs. So for column in names, okay, basically after seeing all the conditions, okay, after seeing all the conditions, I can assume here, okay, so I can say after applying df.columns, I have renamed my columns. So after renaming my columns, you can see these things are very for column in column names. I'm going to print column rate value dot counts. Okay, so high, high, and low. Okay, you can see what type of buying data type it's integer. Name main type it's integer. Name those type is integer. So you can see it here. So let me indicate it for you. So these types we have. Sorry for that. It is integer, integer, integer. Okay. So the name, the column names. Okay. So when I'm going to print my columns, you can see it is a data type integer. Okay. It is a data type integer. Okay. So guys, these are the important. Okay. So after seeing this, after renaming the column and all, okay, after replacing all the columns what we have, okay. So we'll be seeing how it is gonna useful for us, how it will be useful. Okay. So guys, after renaming all the columns, what we have done, we have seen this, and we can see at so how it is useful. Okay, you can see all the data integer types are integer. Okay, all the data types are integer. Okay, so guys, after seeing this, after applying the integer things and all, we will be going with the class. So how many type of value counts we have? So what is our value counts? Okay, what is our counts? So the value counts. Okay, so the value counts, you can see these many things we. So after the value of the counts, we are gonna see. Okay. So after this all thing, so the value of count, we can see the accuracy, the inaccuracy, is the model good, is that very good. Okay. So the name class is nothing but you can see it is data type is integer thing. Okay, integer 64. Okay, same thing here. So after that, I'll be seeing is there any null value in those things? Okay, is there a null value in my columns? So guys, decision tree. Okay, we can't do this all visualization thing if you have a missing values. Okay, so I'm gonna see df.isNull.sum. So I'm gonna say if there is a null value, I'm gonna check do I have any null values in my things? So in my columns, do I have any null values? So I'm gonna check it. For that, I'm gonna write a query df.isNull.sum. Okay, and I'm gonna drop the class axis equal to 1. So why? Because the data frame, you can see, I'm gonna take this class axis equal to 1 in the sense because I'll be having the data type as object. So you can see what all the things I have. Okay, and from the library sklearn.model selection, I'm gonna import train and test splitters. So you know why do we use train and test splitter? Okay, so basically 80 to 20, 70 to 30, first we are gonna send it to the test and we're gonna do the train. So basically it's gonna learn some algorithms, it's gonna do some mathematical equation. Okay, so as I said guys, so let me remember you again. So if the train and test, if it is both are high, then it is a right fit model guys. Okay, right fit model. If train is high and test is low, okay, test is high, test is low, train is high, it is called as overfitting or variance. Okay, and if both are low, then it is called as underfitting or bias. So guys, these things we have in train and test. Okay, in train and test splits, we have these things. Okay, so guys, after seeing, so we have seen how to solve this overfitting. So overfitting we can solve by using regularization, and underfitting by transforming the data. Okay, so guys, after seeing this, after applying all the probabilities, we are gonna see the things which is important. Okay, so when we use train and test split data, okay, when we use train and split data, the next thing will be, so after applying train and split, so the test size is 0.33, the random state. Okay, so X is my train shape and X is my test dot shape. So X train dot types. So when I train my data, I want to see what is the data types I have in my X train. So buying is an object, mate is object, person's object, safety is an object. Okay, and train dot head. So guys, here when I train my data head, you can see the first 5 rows. Okay, so after that, I'm gonna install category encoders, guys. So you can see I have written pip install category encoders. The name says category encoders. Okay, so guys, so what is this category encoder? Okay, so what is this category encoder? Encoding categorical data. Okay, this categorical encoder is a process of converting categorical data into integer format. Okay, so the process of converting categorical data into integer format, so that the why we convert this integer data is, right guys, so that the data with converted categorical values can be provided. Okay, so the models we're gonna improve the predictions. So why did I pip install this encode category encoder? Encoding categorical data is the process of converting categorical data into integer format, so that the data with converted categorical values can be provided, so that the model can give us the improve of the predictions. Okay, so I have installed category encoders and I have got this, and I'm gonna import categorical encoders as C. So we know guys, I'm gonna import pandas as PD. Okay, I'm gonna import pandas to name as PD. The same thing I have done here. And after that, I'm gonna encode variable with ordinal encode. Okay, ordinal means I'm gonna fit transform on tray, and I'm gonna transform on X fit to transform. You can see X train dot head. What all we have? So I have trained here my model. As we know, basically the train data first only learns, because we are going to send the data there and it's going to do some mathematical equation. Okay, then x underscore test dot data I have done, and after that I'm gonna use decision tree to see which is my X train based or is my X test based to buy any model. Okay, so decision tree criteria with Gini index. So what is this Gini index in decision tree? I know it will be a loop, so let me explain. Gini index in decision tree. Gini index is a powerful measure of the randomness of the impurity or entropy in the values of a data set. Okay, so concentrate here, guys. Gini index is a powerful measure of randomness. Powerful measure of randomness, guys. Okay, or the impurity or entropy in the values of data set. So we have seen what is meant by entropy. If both coin has head and tail, if one coin has head and tail, that is entropy. But if both the coin has only head, there is no randomness, guys. So the Gini index is the most powerful measure and used for randomness or the entropy or the impurity of the values of the data set. Gini index aims to decrease the impurities from the root nodes. Okay, one major important thing. This Gini index, decreases the impurities from the root nodes. Okay, as I can say, as the top of decision. Okay, to the leaves. Vertical branches down the decision tree. Okay, for decision tree. So guys, here you can see the Gini index. I have said it is a more it's a powerful measure of the randomness or the impurity of an entropy of the value of the data set. So Gini index aims to decrease the impurities from the nodes, means at the top of a decision tree, to the leaf node, means vertical branches down the decision tree of a decision tree model. Okay. So this is about Gini index. So you can ask me, should Gini index be high or low? Very valid question. Okay, very intelligent question. Should Gini index be high or low? A higher Gini index indicates greater inequality. Higher Gini index, greater the inequality. Okay, guys. And with high income of individuals, we're going to receive larger percentage of the population income. So that is about one. What is a good, you can say, the Gini index good number is Gini index good number is 0. Okay, it represents because it represents perfect. Okay, perfect equality. Okay, guys. So this is the Gini index. The good number is 0 because it represents perfect equality. Okay. So understanding the Gini index and decision, the information in this decision trees, guys. So we have seen entropy and we have seen information gain. So Gini index, guys. If you ask me the conclusion, Gini index and information gain both are used in the analysis of real-time scenarios. Okay, we are going to see how impurity of our data, and we are going to see how data is distributed. So that was how decision tree, okay, explained in Gini index. So here from sklearn.tree, I'm going to import decision tree classifier. So what I'm going to import? I'm going to import decision tree classifier. Decision tree classifier, I'm going to see the criterion of Gini, random state 0. So I'm going to say the prediction of Gini is CLF underscore greeny. Okay. So I'm going to see my array. So the array, after this thing, I'm going to check my accuracy score. Okay. From sklearn.metrics, I'm going to import accuracy score. Okay. From model accuracy score with criterion Gini index, I'm going to format the things. Okay. So here I use Gini index to get because it is the most powerful thing. Okay, it is a most powerful randomness or the impurity or entropy in the values of a data set. Okay, I'm gonna print the model accuracy. I'm gonna score with criterion Gini index. So after all the things which we applied in decision C for Gini index, I'm gonna use format my accuracy for Y prediction of Gini and Y train. Okay, I'm gonna print the model accuracy to score with criterion of Gini index of the data set. I'm gonna use format accuracy score. I'm gonna print model accuracy score. I'm gonna use this Gini index for everything. Okay, I'm gonna use for dot format. I'm gonna see accuracy underscore by prediction, and I'm gonna train my Gini and so model accuracy score with the criterion Gini index for the data set was 0.8021. Okay, it was the accuracy for test data set. So here you can see we have applied Gini index. Okay, we have applied Gini index for the test data. And you can see for the test data, the Gini index for test data set we have got is 0.802. And the criterion for Gini index for data set we have got is 0.786. Okay. So this is what is the model accuracy for applying Gini index. Gini index we have got this. For test we have got is this much. And train we have got this. Okay, guys. So after that, I'm gonna use the graphical thing from sklearn.import tree. I'm gonna tree dot plot. I'm gonna plot a tree using this index. Okay. You can see the Gini index has given us the values. Gini of 0.0. I'm gonna give the samples, the value. Okay. So after getting all the things, Gini has given us the sample values. Okay. Sample values here you can see what is the impurity, the thing, that the entropy which is useful. Okay. So we can here conclude, we can here can see. So what is the useful thing? Okay. So guys, this is all the explanation about decision triggers. So we have loaded the libraries. Okay, we have used all the things which is important to it. We have seen what is high accuracy, inaccuracy, the acceptability. Okay, windows. Okay, and it's for classification. Yeah, use the class. I'm going to use the axis. I have seen my what is the first five values, how to change, how to rename the column. So after renaming the columns, we have imported test and train. We have predicted our data. We are going to use Gini index for the random impureness or the entropy, we can call it. Okay. So after that, I'm going to see the data, the T-like structure. Okay. So here what we have done, we have detected, we have got what is the use of this. Okay, so how we are gonna use decision tree for SR. Okay, so this was all about decision triggers. Okay, I hope it is a good explanation. Okay, about decision tree. Next concept. Okay, so if you ask me the conclusion of decision tree, you can see decision tree has been found useful in classification and prediction, modeling due to the fact which is capability of accurately discover the hidden relationship of insignificant attributes within a data set. It can handle both continuous and categorical variables. The execution of decision tree algorithm must be possible without having to scale the data as well. While utilizing the decision tree algorithm, it is not necessary to create the missing values. So this was all about the conclusion. Okay, so decision tree is done. Next thing we'll be seeing is regression. How automative analytics is used in regression. Okay, so that's linear regression. So what is meant by linear regression? So guys, in statistics, okay, in statistics, the linear regression is a linear approach. This linear regression is a linear approach for modeling the relationship between a scalar response. Okay, it is a linear approach. Is a linear approach for modeling the relationship between a scalar response. One explanatory variables is called simple linear regression. Okay, which has one explanatory is called as simple linear regressions. And if we have multiple variables, it is called as multiple variable regression. So what is mean by linear regression? So guys, linear regression analyzes, okay, the linear regression analysis is used to predict the value of variable. Okay, it is used to predict the value of variable based on the value of another variable. So guys, here you have to concentrate. So linear regression analysis is used to predict the value of a variable based on the value of another variable. The variable you want to predict is called as the dependent variable. The variable you are using to predict the other variable is called as independent variables. Okay. So I hope it is clear. Linear regression analysis is nothing but which is used to predict the value of a variable based on the value of another variable. The variable you want to predict is called dependent variable. The variable you're used to predict the other variables is called as independent variables. Okay. So if you ask me, what are the two main objectives of this linear regression? So guys, we have two type of linear regression: simple linear regression, multiple variable regression. We have simple logistic, we have multiple logistic. Simple linear regression is used to model the relationship between two continuous variables. Often the objective is to predict the value of an output variable based on the value of an input or variable. So guys, if you have one independent variable, it is called as simple linear regression. If we have multiple variables, it is called as multiple regression. Okay, so these things we have this. So which data is most suitable for linear regression? Plotting data is the most obvious and by far the most powerful preliminary to regression. Okay, plotting data. This will be very useful. And why it is called as linear regression? One is linear in variable and other is linear in parameters. The linearity assumption in linear regression means the model is linear in parameters and may or may not be linear variables. Okay. So linear regression. So guys, the linear regression, okay, the linear regression, we have different types. So we have two types less. So let me go with introduction. So we'll be seeing the introduction of linear regression today, and we'll be going with other. So linear regression is a supervised machine learning algorithm. Okay, so linear regression is a, so let me write it, is a supervised machine learning algorithm. Okay, where the predicted output is continuous and has a constant slope. It is used to predict values within a continuous range. Example, sales, prices. Okay, rather than trying to classify them into categories, we have two main types. So first one is simple linear regression. First one is simple linear regression, and next one we have is multi-variable regression. Simple linear regression. So let me explain you about this thing. Simple linear regression. Simple linear regression. Simple linear regression uses traditional slope intercept. Okay, where m and b are the variables of algorithm. Okay, so basically, the most accurate predictions represents our input data, and y represents our prediction. So if you ask me for y is equal to mx plus b, and the next thing we have is multi-variable regression. A more complex multivariable linear equation might look like this. Okay. So guys, this is a simple thing, which is one, you can say one dependent variable or one independent variable is called as simple linear regression. If you have multiple independent variable, multiple dependent variable is called multiple. F of x comma y comma z is equal to w1x plus w2y plus w3. If we have like this, guys, this is called as multivariable regression, where the variables x and y, z represents the attributes. Okay, this x, y represents the attributes. Okay, so the piece of information, like I can say, we have about so much of observations here. Okay, so this is about this. So we have seen this simple linear regressions. Okay, and next thing we'll be seeing is how this linear regression. Okay, we'll be seeing what are the agendas we have in this simple linear regression, and how this linear regression will be helpful for us in automative analytics. So agenda, guys, we have seen introduction of automative analytics, right? In automative analytics, we are going to see linear regression. Linear regression in machine learning, importance in automative analytics, the conclusion. So let us go to the introduction, guys. Linear regression is one of the easiest and most popular machine learning algorithms. It is statistical method that is used for predictive analytics. Okay. So linear regression is nothing but is one of the most easiest and popular machine learning algorithms. Is statistically method which is best for predictive analysis. Okay. So linear regression makes prediction. Okay. So linear regression makes predictions for continuous real or numeric variables such as sales, salary, age, product, price. So guys, linear regression algorithm shows a linear relationship between dependent, one more independent, hence it is called as linear regression. Okay, so you can ask me why it is called as linear regression. Linear regression algorithm shows, okay, a linear relationship between a dependent y and more independent x, hence called as linear regression. Since guys, linear regression shows linear relationship, which means it finds how the value of dependent variable is changing according to the independent variables. So basically, the linear regression is very useful for independent variables. Okay. So as we have seen, introduction of linear regression. Okay. The relationship which finds, okay, okay. So linear regression. Okay. So Since we know there are different type of linear regression, simple linear and multiple linear, we'll be seeing how this linear regression will be helpful for us to apply it in the automative analytics. Okay, we'll be seeing how it is useful for us in applying in automative analytics. So linear regression. Since linear regression is a relationship, we know that. Okay. So guys, you can ask me, what is linear regression best used for? Okay. So we know we are gonna see the introduction part for linear regression. Okay. So linear regression, most precisely I can say, linear regression is used to determine the character and strength of the association between a dependent and series of other independent variables. It helps to create models to make prediction, such predicting companies of stock. So most precisely, linear regression is used to determine the character and strength of an association between dependent variable and a series of other independent variables. So if you ask me, can you give me a real-time example of linear regression? Sure. Linear regression can be used in business to evaluate trends and make estimates or forecasts. For example, if company sales have increased steadily every month for the past few years by conducting a linear analysis of sales data, the monthly sales, the company could forecast sales in 4 months. Okay. That is one is the real-time example of linear regression. How regression is used in daily life? Validation. For example, it can be used to predict the relationship between reckless driving and the total number of road accidents caused by a driver. Okay, an example. If you ask for a reckless driving, we can use this linear regression. We can say the total number of road accidents caused by reckless driving by a driver. If you ask me one more thing, to use a business example, I can say the effect on sales. Okay, the effect on sales and spending a certain amount of money on advertising. Regression is one of the most common models which is used in machine learning. So we have seen this regression. So guys, we have seen the real example for linear regression. What is linear regression best used for? Okay. So the next thing is why it is called as linear regression. One is linear in the variable and other is linear in parameters. Okay. So why it is called as linear regression process? Because one is linear in variable and other is linear in parameters. Okay. The linearity assumption in linear regression, the model is linear in parameters. It may be coefficient of variables and it may or may not be linear in variables. So we know what are the type of linear regression. So if you ask me, what is the another word for linear regression? So rectilinear regression, statistical regression. Okay, these type of things we have. So we have seen linear regressions, guys. Okay. So if you ask me, what are the limitation of linear regressions? Limitations of linear regression. So if you ask what are the limitation of linear regression? Sorry for that. non-linearity of the response predictor, correlation of error terms, outliers are high and leverage. So these type of limitations we have, guys, for linear regressions. Okay. So if you ask me, what is the most important principle in linear regression? So guys, residual and residual plots. The most important measure used in regression for diagnostic is simple residual curves. This is the difference between each observed and predicted value. Okay. So what will be the assumptions which is important for linear regression? The linear regression algorithm assumes that there is a linear relationship between the parameters of independent variables and dependent variables. If this relationship is true, guys, it is not linear because we cannot use the model as the accuracy, which will be significantly reduced. Thus, it becomes important to validate the assumptions. Okay. So let's see linear regression formula. Okay, this takes time. So what is the conclusion we are gonna get? So that is also another thing. Okay, so today we have seen the introduction, guys, the agendas we have seen. So as in the upcoming sessions, we'll be seeing how this linear regression is gonna is useful in automative analytics. Okay. So before going to that, let me explain you about concept of linear regression. So guys, if you ask me what is the concept of linear regression? Linear regression analysis is used to predict the value of variable based on the value of another variable. The concept of linear regression is it is used to predict the value of variable based on the value of another variable. The variable you want to predict is called as dependent variable. So always keep in mind, guys, the variable which you want to predict is called as dependent variable. Okay. The variable you are using to predict other variables. Predict other variable is called as independent variable. Okay, this is the concept of linear regression. Okay, so linear regression is analysis used to predict the value of variable based on the value of another variable. The variable you want to predict is called as dependent variable. The variable you want to predict using other variable is called as independent variable. So guys, this is all about linear regression. We'll be going detailedly in the upcoming session. So in case if you have missed any sessions, guys, I always suggest you to go and watch the recorded videos. If you have interested, you can always go and search of automative analytics. And I have shown you how this clustering, KNN, decision tree is useful in finding automative analytics. So guys, in tomorrow's session, we'll be seeing how this linear regression is gonna be useful for automative analytics. What all concept we can apply in machine learning. Okay. How this linear regression is gonna give us the importance of automatic analytics. So how we are gonna use one dependent variable to one independent variable. So these amazing things we'll be seeing in the upcoming sessions. So make sure you attend the session. Okay. So guys, this was all about for today's session. So thank you for attending. The domain analytics is sponsored by 360DigiTMG. So make sure you watch all the recorded videos in case if you have missed anything, guys. Okay. So take care. We'll be seeing you in the next session.